Have you ever been out enjoying your preferred winter sport when your feet have gotten cold? It can really put a drag on an otherwise good time, and unfortunately, no matter how many beers you have to try to rectify the matter, it just doesn't go away. So, the premise of this video is I'm going to do something about that. I am going to make electronic boot heaters inexpensively with stuff that I have laying around the house, and some things that I had to order, but none of it's very pricey. These boot heaters have been tested, they work, and I give a quick review of them at the end of the video, so you might want to stick around for that. Here's a schematic showing the basic premise of them. As you can see, they use a USB phone charger, like what you'd use to recharge a dead cell phone, the existing insoles for my boots, an old USB cable, and some flexible heating elements that you can get pretty inexpensively on Amazon. In the remainder of the video, I explain some of my design process and show you how I put them together. What's up, people? I'm going out on maybe a bit of a limb here, but I am going to suggest that perhaps at some point in the past you have had cold feet. Right now I want to come up with an inexpensive and simple way to address this common issue. For my case, I'm going skiing soon. I've had cold feet in the past while skiing, but now I have some crap laying around the house that I think I can use to rectify this matter, and I'm going to try to do that. So here's kind of the heart of what's going into this. These little warming pads that, well, you can see the specs on them. They're meant to run on 12 volts at 7 watts, just little flexible heating pads. I actually got them to heat that fish tank over there, and for that they do very well. I have 2 of them at the bottom. It's set at 12 volts with a variable voltage power supply. It keeps the water at a nice comfortable 78 or so degrees that the fish over there, Killer Mike, really enjoys. So my idea is to use these leftover heat things that I didn't need for the fish tank in conjunction with a phone charger battery bank to make something that I can kind of incorporate into these insoles to have nice toasty toes while I ski. So I guess first we have to do a little bit of math to see if this is even plausible. And what will determine if it's plausible or not is whether or not these things run at an amperage that this particular battery bank is able to put out. So step 1 in that is just doing some basic equations here. I'll walk you through it. If you remember only 2 equations with electronics, these are probably the ones you want to know. V equals IR. Voltage equals current times resistance. The other one is power equals current times voltage. So here we can take some of the knowns that we have from the package and determine how much current these things will draw when running at 5 volts. So we'll start with what we know. At 12 volts times I, that's our unknown, it equals 7 watts. Current is in amps. V, that's volts. Break out a calculator here. Come on. GoPro software freezing up on me. 7 divided by 12, 0.583. Okay, so now we want to know how much resistance these things have. So at 12 volts and it running at 0.583 amps, we can move these around to get the resistance. R equals 12 divided by 0.583. That's 20.58. Alright, that's how much resistance is supposedly in here. We can do a quick check now and see if that's right because I have a meter over here. I can either kind of confirm or deny that. This thing's kind of doing its thing and settling. So it's measuring 20.1 ohms, 20 ohms. Alright, so we just measured 20 ohms. We calculated 20.58. That's very close. That's like 0.5% difference. I'd say we are off to a good start. This thing's kind of doing its thing and settling. So it's measuring 20.1 ohms, 20 ohms. Alright, so we just measured 20 ohms. We calculated 20.58. That's very close. That's like 0.5% difference. I'd say we are off to a good start. So what we need to know now is how much current this thing will draw at 5 volts. So for back to this equation, V equals IR, we'll plug in 5 volts equals I, and then we want to divide it by 20.58 ohms. And that'll leave us with 5 divided by 0.243 amps. Alright, so I am going to be running 2 of these things because I have 2 feet. That is going to bring us up to 0.48 total load. About half an amp at 5 volts. That's reasonable. You know, a phone, that's kind of where a phone could be expected to charge. You know, with fast chargers, of course, they go faster, up to, you know, maybe 2 or so amps. But an old device might run at 0.48. So that means that the circuitry in this can support it, and not only support it, but, you know, register as being a significant enough load for it to actually stay on and continue outputting power. Because these things also have a little bit of smarts in them to detect if a thing is done charging, and then they shut down. So if this number is too small, this could maybe shut down and stop delivering power prematurely, and then your feet are going to get cold, or you'll have to turn it back on, or whatever. So, you know, at least this is in kind of a plausible range where we might avoid having that issue. One thing that I didn't mention is, you know, with these things being meant to run on 12 volts, obviously you can run them at a lower voltage. It won't be destructive to them, but will it still work? Yes, it'll just kind of output less heat. The thing is, at 12 volts, I have this experience from using them on that fish tank, that they put out quite a bit of heat at 12 volts. You wouldn't want that touching your skin directly. It would be really uncomfortable. So 5 volts, on the other hand, it's reasonable, and you're not going to have so bad of a time with that. It should just be comfortable. But, you know, once I reach the end of this project, we'll have an answer there. So I think what I'm going to start out doing before actually trying to get these heaters into the boots and tearing up my insoles, I want to wire it all together just to make sure that this works. As I've done the math, it's plausible. Now I kind of have to test it. So first up, I have to add some wires to these, extend them. So I don't really want to have to redo it. This is one of the few things that I bought for this project. All I really bought for it was this wire, some connectors. You know, I only needed 2, but when you buy stuff from Amazon, sometimes you get larger quantities than you really need. And I also got some of this marine grade heat shrink, which is just heat shrink with a glue in it, so that when you heat it up, the glue kind of melts and you end up with a water resistant connection. I'll just make these leads a little bit long, and then I can trim them to the desired length later. And I should start heating up my soldering iron. Research time for this one to work. Where did it go? These are just simple resistive loads. Polarity doesn't matter. Hook them up however you damn well please. Definitely could have gotten away with thinner wire here. In hindsight, maybe I should have gotten some thinner wire because then I'd have, less stuff in my boots competing with my feet for space. But one reason why I chose this thicker wire is it's going to be kind of robust, and I don't have to worry about tearing it so much. It's also nice that it's in this jacket, so I think it'll hold up better to sustained use. All right. I don't know if you can tell, but you can kind of see what makes this marine heat shrink. There's a bit of transparent goo that's kind of coming out of these now that they're heated up. And that is to help keep them waterproof. So my next move is going to be to to prep the ends of these, strip them. Then I'm going to take this USB cable and chop it. This is what's going to plug into the battery bank and translate, the USB port that this thing has over to just basic 2 wires going to a resistive load. This is the time where I can stretch your fingernails. There we go. I cut these things longer than I actually need them, so I'm not too worried about destroying the ends. This is just for test purposes right now. Is it going up? Glad I have this in here. Sorry, go, bro. So I'm going to use the headphones in. I guess being a digital data cable, it has a lot of shielding inside of it to keep your ones and zeros as ones and zeros. Now the only things in here that I care about are these black and red wires. So everything else it's going to get chopped. Bit of a haircut there. So thin. I really could have gone a lot thinner than this with the wires. Or who knows, maybe these wires will put out as much heat as the foot warmers themselves. And yes, it's janky, but I'm just kind of doing a quick proof of concept right now to see if these things will heat up. And not just heat up, but, you know, kind of stay warm at a usable temperature where they can make a meaningful difference in keeping my feet warm. Okay, so let's see, I think these different USB ports did different things. USB 1 had a 1 amp max limit. I guess I'll just plug it into there, since we should only be drawing half an amp. See what happens. So this is lighting up. It's putting out power. Plop this under here, so hopefully it's an angle where you can still see that. Yeah. We got heat. An appreciable amount. Just a second. Okay. So we'll just get a baseline temperature of the countertop here. That's at 73 degrees 74. And if we point it at this, you see we're pumping out a little bit of heat there. 140 degrees. Yeah, same thing on this one. With these guys running at less than half their intended voltage. Now it doesn't feel uncomfortably hot. It's just, you know, maybe exactly what you'd want to have in your boot with your toes to keep them nice and toasty. I'm just going to let these things run for a while to make sure that the power supply stays on. But, you know, so far so good. One thing that we can do is calculate how long this thing will run for. So we know that it runs at, let's call it half an amp, 0.5. And this is a 30,000 milliamp hour battery, which is a 30 amp hour battery at 5 volts. So if you want to know how long it'll run for, all you have to do is take this 0.48 amps, divide it by this. See, the A's cancel out, so you're just left with hours. And how many hours will it run for? 30 divided by 0.48, 62.5. That's pretty damn good. You know, a lot more than I actually need. As I've maybe skiing for a weekend. I got 2 full day passes. Let's say I ski and run these things for 8 hours a day. That's only 16 hours. And also, you know, you sleep too, so you can recharge your batteries while you sleep. That's no big deal. So I don't actually need this big of a battery bank to keep these things going for a full day of skiing. You know, I guess the benefit of something like this is if you want to ski all day and keep your devices charged and all that, it might come in handy. But if your goal is just to keep your feet warm, you might be able to get away with 2 small battery banks and then just strap them onto your boots. Then you don't have any wires going through your snow pants or anything else inconveniencing you. Just a thought. I think for the first round of this, though, I'm just going to keep it with a central battery source that's just going to sit in my pocket. These feel really warm right now. This is awesome. Okay, well, I'm content with saying that this works. The next step is to come up with something to put in my boot. These guys are a little bit small. I don't want to just do this. One, because it's going to concentrate all the heat kind of between the balls of my feet and the tips of my toes. It can't really go all the way forward because it's a rectangle. What I can do to deal with that is have something to distribute the heat. And that's where this sheet of aluminum comes in. You see this guy here? I think what I'm going to do is trace these on here. And then I have something that'll warm my whole toe area. And it'll do that because aluminum is a phenomenal conductor of heat. Like if you look inside your computer or whatever, you'll probably notice that the heat sinks are typically made of aluminum. It's because it's really good at taking heat and moving it from one place to another. So if I put one of these pads kind of in the center of this, it'll take that heat and distribute it pretty evenly over this whole thing. And it's moderately thick too. I don't remember exactly what this sheet is. It's just some scrap I had in the garage, but it looks like it's over 1/16 of an inch thick. Maybe it's right about there. It's still thinner than this, so it'll fit in the toe. I'm just going to have to trim these things down to accommodate it, and hopefully I won't mind having, or maybe I'll fillet this so that the soft part glues down to this instead. Whatever, we'll see. Tin snips are not the right tool for this, maybe. Should I take that back?
Okay, yeah, these don't feel that impressive.
Yeah, somebody thought that these little things did a better job than these shits. She broke these things out.
I didn't say that.
She's not impressed.
I didn't say that.
Meanwhile, over here, we're rocking, ooh, nice and warm.
I just want to do a product comparison, Kurt.
But anyway, I'm going to try to pare these things back so this hard bit is gone, and then they can be replaced with this hard bit. And that way there's still like some continuity in this thing, and it won't feel weird on your feet if the felty top bit is still there. So, I don't know. Scalpels surgery, here we go. Alright, not too bad. This thing can go bye-bye. And once these aluminum things are sanded down, it's going to fit nicely under here. Could probably use some spray adhesive or something to bond them together. It'll be like it was meant to be this way. Cool. Moved out to the garage. I've got these things. I want to smooth them out, get rid of the sharp edges. and also help them follow the contours of the lines. And in order to do that, I am going to use this belt sander here. One thing to note when you're doing stuff with aluminum that's going to be producing dust, you want to wear a mask because aluminum is associated with Alzheimer's, and unless you like the idea of forgetting your kids' names and repeating the same 5 stories over and over again, you know, maybe protect yourself from the dust. That one. Alright, these are reasonably smooth now. Not perfect, but they don't need to be. They just need to, you know, not cut up your toes or the insides of the boots or whatever. They still could use a little bit of flattening out, but that's easy enough. Got tools for it. So now I want to flatten these things out. They're pretty flat, to be honest. I could probably use them as is, or just straighten them out with pliers or whatever. But, you know, I've got a hydraulic press here, so why don't I just drop 20 tons on them and call it a day. Hitting the internal bypass of this thing. So that means we've got 20 tons on there. I don't know, maybe it's flatter. Yep. I think so. And now to show how all of this goes together. The insoles obviously go into the boots. The wires run up behind the tongues here. The wires attach to the top of the boot itself to provide a strain relief. That way if you tug on the wire, the insoles aren't damaged or the heating elements aren't damaged. And then here is a Y splitter that goes from the boots to the battery pack. And it's set up on connectors so that you can run these things down the legs of your snow pants and then just plug the boots in. Now that I've worn these a couple of times, I can point out some issues with them. The main issue is the quality of some of these components. These connectors are kind of garbage. There's supposed to be like a retention tab here, so these snap together. That broke. This one broke as well, but even more so. That's why you, I guess ideally don't buy cheap Chinese junk on Amazon, but you know, sometimes it's okay. In this case it's not. The wire isn't so great either. As you can see, the insulation on it broke here and also here. No showstoppers. It'll continue to work, but if I make another version of this, those are some things that I can improve upon. So it's probably time I give an update on these boot warmers. I've been skiing on them all day, and I've got to say, these things at 5 volts is the sweet spot. Any warmer and I think my feet would be sweating, but right now they're totally comfortable after several hours, and that's kind of a game changer for me, because it used to be that after, you know, maybe a half hour out, my feet would be freezing, like kind of numb, like I'd be worried about nerve damage. Have to go in and warm up, but now I can just keep going and going and going. These things are only running at 5 volts and they're kicking ass. Wouldn't want them any warmer, wouldn't want them any cooler. I've got to say I recommend them. Build some